The year was 1944. The Eastern Front had turned. The relentless German drive had been reversed, but the grinding, bloody reality of armored warfare had been redefined by the monsters the Wehrmacht was now fielding. The Soviet Red Army was winning, but every victory came at the terrible cost of tank losses. The new German beasts, the Panzerkampfwagen VAZ B, the King Tiger, and the formidable Jagdpanther tank destroyer, had ushered in an era of armor thickness and gunpowder that outstripped every vehicle in the Soviet arsenal. While the magnificent IS-2 Iosif Stalin II was a superb heavy tank, its 122mm gun struggled to reliably penetrate the King Tiger's glacis plate at range. The tank designers, known collectively as the SKB Special Design Bureau, were under unimaginable pressure. In the fortified bunkers and deep industrial shops of Tankograd, the sprawling industrial complex centered around Chelyabinsk, the mandate from the GKO State Defense Committee was clear: build a counter-monster. Build something invincible. The specifications of madness. Deep beneath the Chelyabinsk Kirov plant shacks, in a subterranean design office filled with stale cigarette smoke and the omnipresent hum of wartime industry, a small team of engineers gathered around a set of blueprints that defied everything they knew about armored warfare. The chief designer, Engineer Viktor Volkov, a pseudonym used in internal reports to shield the true architect, looked at the drawings with a mix of awe and dread. The specifications were dictated not by physics, but by Stalin's unwavering demand for absolute superiority. Weight: in excess of 150 metric tons. The final design pushed this boundary, ballooning to 178 tons. This made it heavier than any bridge in the operational zone of the USSR. Existing heavy tanks like the IS-2 weighed around 46 tons. The heaviest German operational tank, the King Tiger, topped out at 68 tons. Volkov's creation was nearly 3 King Tigers welded together. Armament: a gun larger than any artillery piece ever mounted on a mobile chassis. The requirement was a weapon that could not only penetrate the King Tiger at 2,000 meters but obliterate it. This necessitated stepping up to a naval or heavy siege mortar caliber, likely a 130mm or 152mm naval cannon. Armor: armor so thick that no German weapon, not even the feared 128mm gun of the Jagdtiger, could penetrate it. The frontal glacis was specified at a mind-boggling 300mm of sloped, hardened steel. It wasn't a tank, it was a land battleship, a moving fortress designed to withstand a direct artillery barrage and crush any opposing fortification or vehicle purely through its sheer mass and destructive power. The dismissal: Engineer Volkov, a man whose entire career was dedicated to practical, reliable design, wrote his official technical assessment with a heavy hand. His report, filed in June 1944, laid out the impossibilities with cold, factual precision. Propulsion: no engine exists to move such a vehicle. The weight exceeds the power-to-weight ratio achievable by any twin-coupled diesel currently in production. Any attempt to use standard transmissions will result in immediate catastrophic gearbox failure. Metallurgy: no steel mill in the Union, operating under wartime strain or otherwise, can reliably forge or cast a 300mm plate of this size and uniform hardness. The internal stresses alone risk fracture upon firing the main armament. Logistics: no road or bridge could support it. Its operational radius would be limited to prepared railway transport or solid, dry ground. It would be a static defensive weapon, not a mobile breakthrough vehicle. The report concluded, in the blunt language of the Soviet military design hierarchy, the design cannot function under combat conditions. It is physically, technically, and logistically impossible. The blueprint, the dream of an invincible monster, was officially dismissed. It was filed away, labeled Project 44A HVY, and forgotten in the archives. The design bureaus were ordered to focus on reliable IS-3 production. Yet, in late 1944, months after its technical death, someone approved it. The order was cryptic, coming not through the normal channels of the NKTP, People's Commissariat of Tank Industry, but directly from a highly placed member of the GKO, bearing the signature of Marshal Ustinov, Stalin's trusted industrial commissar. The order commanded the reallocation of the finest engineering talent and the rarest metallurgical resources, usually reserved for aircraft or nuclear projects, to Volkov's impossible vehicle. By early 1945, something vast, menacing, and utterly defiant of the laws of war, began taking shape in the snow-covered, heavily guarded yards of a secret testing ground in the Ural Mountains. A monster the Red Army never intended to build, and couldn't control once it existed. The P stood for a word Stalin himself reportedly used when he first saw the initial, terrifying sketches of the tank's bulk, Pobeditel. The Victor. It was a name of ominous pride, a preemptive declaration of victory over both the enemy and the laws of physics. The specs of the Victor. As the vehicle was assembled, its sheer scale eclipsed every armored vehicle ever conceived outside of Hitler's own delusion, the Maus. Weight: 178 tons of steel, rubber, and complex machinery. Armor. Frontal plating was a massive 295 mm, slightly under the target, but achieved by an unprecedented triple-layer casting process sloped at 45 degrees. It was, for all intents and purposes, impenetrable by any gun in existence in 1945. Armament. The primary gun was the 130 mm S-70 naval cannon, adapted from a destroyer's main battery. This weapon fired a shell capable of piercing over 250 mm of armor at 1,000 meters. The sheer recoil necessitated a turret ring nearly 4 meters in diameter and a complex hydraulic damping system, without which the tank would simply flip itself over backward upon firing. Mobility. Its tracks were immense, over 3 meters high and nearly a meter wide, designed to distribute the impossible weight. They were taller than an average man, turning the tank into a mobile wall of steel. Object P was a tank that could survive anything, if it could ever move. The central, insoluble problem remained: propulsion. The forbidden solution: the proto-hybrid drive. The standard Soviet answer to heavy weight was to couple two powerful, high-output diesel engines, such as the V2 series used in the T-34 and IS-2. But even two coupled V2 engines could barely budge 178 tons without destroying their mechanical transmission within minutes. The design team was forced into a radical, almost heretical choice: electric drive. This technology, known as diesel-electric transmission (DET), was primarily found in massive systems: naval warships, submarines and carriers, and giant railway locomotives. It had only ever been tried on a handful of tank prototypes, most famously, the German Ferdinand heavy tank destroyer, with catastrophic results. Object P had a propulsion system that belonged in a power plant, not a battlefield. The heart of the system was deceptively simple, terrifyingly complex. The generators, two paired, high-output V12 diesel engines adapted from aircraft or heavy-duty tractors, ran constantly at maximum RPM, not connected to the tracks, but coupled directly to two colossal electric generators. The transmission. The generators produced an enormous, fluctuating electrical current. The motors. This current was fed through thick, braided cables to 4 independent electric motors, housed in the track units, one motor for each track section, providing the motive power. This system offered an undeniable advantage: massive, instantaneous torque. Electric motors can generate maximum rotational force immediately, allowing the 178-ton tank to theoretically move from a dead stop with surprising speed. It also eliminated the fragile mechanical gearbox and clutch. But the risks were exponential. The designers, led by the horrified but duty-bound engineer Volkov, warned: risk of ignition, risk of overload, risk of runaway power state. Translated from the dry, technical Russian, it might blow up. The insulation might melt and cause a massive fire, or simply run away on its own. Both predictions would prove true. The realization of Object P was a staggering feat of wartime industrial hubris. To build a machine that was theoretically impossible, the Soviet industry had to bend its own rules and break its own tools. The construction process itself was a battlefield. Tankograd's sacrifice. The task fell to Chak's Chelyabinsk Kirov plant, affectionately known as Tankograd. By 1944, Chak's was the largest tank factory in the world, a relentless machine that churned out IS-2s and self-propelled guns, springs, in dizzying numbers. But Object P demanded a suspension of normal production schedules. The most intense challenge was the armor. Forging a 300 mm plate of high-hardness armor steel, with the required slope and size, was not a matter of simply pouring more metal. The foundry nightmare. The huge furnace molds had to be specially fabricated. The cooling process for such a thick casting took days, not hours, risking uneven hardening, internal voids, and micro-fractures. Several massive frontal glacis plates cracked upon cooling, wasting thousands of tons of precious, nickel-rich alloy steel. The scrap pile around the dedicated Object P forge was larger than the production output of a small factory. The turret ring. The turret and its immense 130 mm gun weighed nearly 50 tons alone. The turret ring, the circular bearing that allowed the gun to traverse, was a precision-machined steel collar over 4 meters wide. Welding and machining this piece alone required specialized, rarely available equipment, diverting resources from the entire IS-2 assembly line. The assembly hall of dread. When the components finally reached the assembly hall, a special bay cleared of all other activity and perpetually monitored by NKVD security officers, the crew selected to operate the behemoth got their first look. The tank was so tall that mechanics required ladders to reach the top of the tracks. The hull was so wide that its sheer presence seemed to warp the perspective of the building around it. Chief Engineer Volkov oversaw the most sensitive step, the installation of the diesel-electric drive. The coupling of the two high-output diesels to the massive generators was a vibration-sensitive operation. The cables, thicker than a man's forearm, insulated with heavy rubber and asbestos, were run through sealed conduits along the belly of the tank to the 4 electric drive motors. The whole system was a dense knot of high voltage and high heat. When the coupled diesel generator was first ignited, the sound was not the familiar roar of a tank engine. It was a terrifying, deep, vibrational rumble, like a small freight train operating in a sealed room, immediately followed by the high-pitched, ozone-laced whine of the spinning generators building their electrical charge. The vibrations in the hull were so severe that precision optical equipment had to be mounted on separate shock-absorbing pedestals. The crew knew instantly. This machine was not engineered for the battlefield, it was engineered for raw, explosive power, barely contained within its steel shell. By early 1945, the single, complete prototype of Object P was loaded onto a specialized, reinforced railway flat car, one of only 2 in the entire region capable of bearing its weight, and transported to a remote, snow-covered testing range deep in the Ural Military District. The site was known as Polis 17. The crew, electricians, not tankists. The operating crew was hand-picked. They were not traditional tankists. They were an elite mix of naval engineers, familiar with large-scale diesel-electric installations, electrical specialists, required to monitor the highly temperamental voltage regulators and current feeders, artillerymen, required to master the complex, hydraulically assisted loading and firing cycle of the naval gun. The commander, Major Yevgeny Petrov, a veteran of Kursk, viewed the vehicle with quiet terror. He was used to the raw mechanical violence of the T-34. Object P felt cold, intellectual, and infinitely more dangerous. The first test. Silent torque and smoking insulation. The first mobility test was conducted under the sharp, gray light of a February dawn. The procedure was cautious. Engage the diesel generators, allow the current to stabilize, and slowly feather the power regulators. The initial movement was astonishing. The 178-ton behemoth began to move almost silently, driven purely by the immense, smooth torque of the electric motors. There was no jarring clutch, no grinding gearbox. The movement was deceptively fluid, an unnerving glide across the packed snow. It felt less like a tank and more like a massive, unstoppable railway car. The sheer power immediately solved the mobility problem. Object P could crawl over trenches, crush fortifications, and maintain speed uphill without the engine strain that plagued mechanically driven heavy tanks. But the advantages were short-lived. On the second day of sustained running, when Major Petrov attempted to put the tank through its paces, a rapid acceleration followed by an immediate stop, the first sign of the risk of ignition became apparent. As the electric motors surged to full power and then suddenly reversed polarity to act as electromagnetic brakes, the system was overwhelmed. The overload, the massive current surge was too much for the cooling oil and the asbestos insulation. The smoke, a dense, acrid cloud began pouring from the engine bay and track housings. It wasn't diesel smoke, it was the sharp, metallic smell of burning electrical insulation and superheated oil varnish. The heat. Inside the fighting compartment, the heat was unbearable. The conduits carrying the thick cables to the track motors became hot enough to blister paint. The test had to be immediately aborted. The engineers frantically worked to decouple the diesels and shut down the generators. The realization hit them. The electric drive provided the raw power needed, but it had no safety margin. The system was designed for continuous, predictable operation in a stationary power plant, not the brutal, stop-start, high-impact demands of a tank maneuver. Every rapid acceleration or quick direction change threatened to turn the entire machine into a 178-ton oven of molten copper and burning rubber. The technical report back to Volkov was stark. The propulsion concept works, but the motors lack sufficient thermal damping. Continued operation risks total electrical conflagration. The defining disaster, the moment when Object P transitioned from a technical marvel to a terrifying, uncontrollable beast, occurred 2 weeks later, during a maximum speed endurance test. The engineers had implemented temporary cooling fixes, and the GKO had demanded a demonstration of combat speed and sustained power. The electrical team, under immense pressure from Major Petrov and the overseeing NKVD political commissar, attempted a prolonged run across a frozen lakebed. The critical failure. The generator loses control. The principle of the diesel-electric drive relies on the precise regulation of the current produced by the generator and fed to the motors. A tiny, critical circuit, the voltage regulator, was responsible for translating the driver's throttle input into manageable electrical output. The shock and vibration from the earlier test runs had subtly damaged the regulator unit. As the tank hit a section of rough ice, the critical component short-circuited. The surge. The regulator failed in the open position, allowing the full, unmanaged current from the twin, high-revving diesel generators to flood the system. This was the moment the designers had feared, the runaway power state. In the control room, the chief electrical officer, Lieutenant Ivan Krylenko, saw the main ammeters violently slam to their maximum pegs, the needles instantly bending against the casing. The motors received a massive, unregulated spike of power, equivalent to several times their maximum operational current. The beast unchained. The effect was instantaneous and terrifying. Object P, which moments before had been lumbering along at a respectable 25 km per hour, suddenly lurched forward with the catastrophic, silent force of a lightning strike. The immense, 178-ton hull became a projectile, accelerating with a horrifying electric urgency. Major Petrov, seated high in the turret, roared the order to stop. The driver, struggling against the suddenly unresponsive controls, slammed the emergency disconnect, but it was too late. The magnetic field in the 4 massive drive motors was energized far beyond the limits of control, locking them into a state of unstoppable, high-speed rotation. Object P was running away on its own. The speed quickly climbed, 35 km per hour, then 40 km per hour, a terrifying velocity for a vehicle designed to weigh 178 tons. The gigantic tracks pounded the frozen earth, tearing up deep furrows. The noise was apocalyptic. The sustained, banshee howl of the generator and the deafening clatter of the tracks as the tank shook itself violently. The crew was trapped inside a self-propelled disaster. They were thrown against the steel walls as the behemoth veered wildly, ignoring the driver's steering input. They tried the main emergency brake, a mechanical caliper system intended only for parking, but the sheer momentum of the 178 tons of steel simply vaporized the brake pads in a flash of heat and sparks. The tank ripped across the testing range, obliterating everything in its path. A concrete observation bunker was crumpled into rubble, a reinforced anti-tank barrier was flattened as easily as cardboard. The hull flexed and groaned, stressed by forces it was never meant to withstand. The halt. The unstoppable run lasted for 7 nightmarish minutes, covering nearly 6 kilometers of testing ground. Object P finally came to a shattering halt not through human control, but because the extreme heat generated by the uncontrolled current finally caused the 4 electric drive motors to catastrophically fail. The copper windings melted, the bearings seized, and the system collapsed into a mass of fused, inert metal. The tank bucked violently one last time, shedding 2 entire track sections, before settling into a smoking, silent ruin on the edge of a pine forest. The crew, shaken and bruised but miraculously alive, scrambled out, escaping the now smoldering hull. The victor had become a victim of its own impossible power. The technical prophecy had come true. It had run away on its own, and in doing so, had destroyed itself. The aftermath of the runaway incident was immediate and politically explosive. NKVD security teams swarmed the site, immediately seizing all data and debriefing the terrified crew. Major Petrov's report was delivered straight to the GKO. The verdict was damning, yet tinged with reluctant awe. The technological failure. Engineer Volkov, flown in by special aircraft, inspected the wreckage. The hull was sound, the 300mm armor pristine, and the gun fully operational. It had survived the structural trauma. But the propulsion was a complete loss. The final technical report, written in the spring of 1945 as the Red Army stormed Berlin, detailed the fatal flaws of the Object P concept. Uncontrollable power. The electric drive, while offering maximum torque, was inherently unstable under combat conditions. The risk of the runaway power state was unacceptably high. The margin between full power and catastrophic overload was too thin. Logistical complexity. The repair of the system required highly specialized electrical engineers, not field mechanics. Replacing a fried electric motor assembly was a logistical nightmare that could not be sustained on the front lines. Wartime resources. The amount of copper, nickel, and specialized insulation required for one Object P could outfit 10 IS-3 tanks. The report concluded that Object P was a technological dead end for the Soviet tank corps. It worked, but it was uncontrollable and unreliable. Its complexity was a logistical nightmare for wartime production. The scrap order. The decision came directly from Stalin. The project was cancelled, and the prototype was to be dismantled immediately. There would be no further testing, and no production. The very existence of Object P was to be expunged from all but the highest-level security archives. The secrecy surrounding its dismantling was absolute. The single, immense prototype of Object P was cut up on site by heavy torches, a laborious, multi-week process due to the thickness of the armor. The scrap metal was quietly reassigned to other projects, and the testing ground was leveled and reforested. The memory of the impossible tank was buried, a ghost in the archives, a silent testament to wartime hubris and technological terror. The legacy of the victor. Yet, the immense effort and the terrifying failure were not entirely in vain. The concept of the diesel-electric transmission, pioneered and destroyed by Object P, proved its mechanical feasibility under extreme load. The lessons learned about high current regulation and high torque electric motors were later applied successfully not to tanks, but to specialized military and industrial applications. Heavy railway artillery. The extreme precision of electric drive was ideal for moving and aiming colossal railway-mounted siege guns. Heavy mining equipment. The constant, massive torque was perfect for the immense excavators and industrial vehicles developed during the post-war Reconstruction era. The Project P, the victor, never reached the battlefield. It was a momentary glimpse into a future of armored warfare that was simply too powerful and too volatile for the technology of 1945. It remains one of the Soviet Union's most extraordinary secrets, the impossible tank that worked only on paper, and in reality, was defeated only by the uncontrollable fury of its own power. The heart of the Soviet war machine was Tankograd, the sprawling industrial complex centered around the Chelyabinsk-Kirov plant Chaks in the Ural Mountains. This was where the entire Soviet heavy tank production had been relocated and consolidated, becoming a city-sized factory where the air was thick with the rhythmic pounding of steam hammers, the acrid smell of hot slag, and the relentless, high-pitched whine of machinery that ran 24 hours a day. The motto here was Rabota, Voina, Pobeda, work, war, victory. In the fortified bunkers and deep industrial shops of Tankograd, the pressure was not merely professional, it was a matter of survival. Designers worked under the immediate authority of the GKO, State Defense Committee, a body directed by Stalin, which demanded immediate, infallible solutions. Failure meant the Gulag. It was here, in a subterranean design office located beneath the clamor of the main assembly halls, that the seed of Object P was planted. The room was illuminated by harsh, bare light bulbs hanging from thick electrical cords, filled with stale cigarette smoke, and vibrating constantly with the distant, powerful hum of the great plant. The small team assigned to this theoretical counter-monster was led by engineer Viktor Volkov, a pseudonym used in internal reports, his true identity a carefully guarded secret. Volkov was not a romantic, he was a pragmatist. A man with a deep, almost spiritual reverence for the immutable laws of physics and material science. His designs were known for their elegant simplicity and robust reliability. When Volkov received the initial concept specifications, which had been filtered through several layers of political and military hyperbole, he looked at the drawings with a mix of awe and profound technical dread. The requirements were dictated not by engineering possibility, but by Stalin's unwavering, almost mystical demand for absolute, psychological superiority on the battlefield. The vehicle had to instill terror in the enemy and invincibility in the crew. Volkov laid out the terrifying technical specifications on a massive drafting table, his pencil sketching figures that instantly exceeded the limits of known engineering practice. Weight requirement: in excess of 150 metric tons. The final, preliminary design sketch pushed this boundary, ballooning the theoretical mass to 178 tons. Volkov calculated that this machine would be heavier than any temporary military bridge and most permanent civilian railway bridges in the operational zone of the USSR. The standard bearer of Soviet heavy armor, the IS-2, weighed a mere 46 tons. The heaviest German operational tank, the King Tiger, topped out at 68 tons. Volkov's creation was nearly 3 King Tigers welded together. The ground itself would fail beneath it. Armament requirement: a gun larger than any artillery piece ever mounted on a mobile chassis. The requirement was not just penetration, but obliteration of the King Tiger at 2,000 meters. This meant discarding the standard 122 mm and stepping up to a naval or heavy siege mortar caliber, likely a 130 mm or 152 mm naval cannon, weapons whose recoil forces were meant to be absorbed by tons of ship structure or deep concrete emplacements, not a mobile chassis. Armor requirement: armor so thick that no known German weapon, not even the feared 128 mm gun of the Jagdtiger tank destroyer, could penetrate it. The frontal glacis was specified at a mind-boggling 300 mm of sloped, hardened steel. This plate alone would be taller and wider than many of the small wooden houses that lined the industrial city streets. Volkov saw immediately that this was not an evolution of tank design. It wasn't a tank. It was a land battleship, a moving fortress designed to withstand a direct artillery barrage and crush any opposing fortification or vehicle purely through its sheer mass and destructive power. The logic was simple: a war of attrition is won by the side that can field a weapon the enemy cannot destroy. Volkov, a man whose entire career was dedicated to practical, reliable design, wrote his official technical assessment with a heavy hand and cold, factual logic. His report, filed in June 1944, laid out the impossibilities in excruciating, apolitical detail, addressed only to the NKTP, People's Commissariat of Tank Industry. I propulsion: the power equation. No diesel engine exists in the Union, under current or projected development, that can be twin-coupled to achieve the necessary power-to-weight ratio to move 178 metric tons reliably across anything but paved or frozen ground. Any attempt to use standard clutch and transmission systems, even from heavy artillery tractors, will result in immediate catastrophic gearbox failure upon application of load. The vehicle will be born immobile. 2. Metallurgy: the integrity of mass. No steel mill in the Union, operating under the severe strain of wartime production, can reliably forge or cast a 300 mm plate of this size and uniform hardness without unacceptable internal stress inclusions. The required annealing process is too long. The final armor plate will be brittle. Furthermore, the immense stress imparted by firing the main armament will likely fracture the hull structure regardless of its thickness. 3. Logistics: the unplayable game. The operational radius would be zero. No road surface could withstand its mass without immediate destruction. Its movement would be limited entirely to prepared railway transport or solid, dry ground. It would be a static defensive weapon, an anchor, not a mobile breakthrough vehicle essential to the Red Army's dynamic counteroffensive. The report concluded, in the blunt, uncompromising language demanded by the Soviet military design hierarchy, the design cannot function under combat conditions. It is physically, technically, and legally impossible. The project must be cancelled. The blueprint, the dream of an invincible monster, was officially dismissed. It was filed away, labeled Project 44A HVY, and relegated to the archives. The design bureaus were ordered to focus their strained resources on the reliable and necessary IS-3 production. Section 1.6. The approval that came from the shadows. Yet, in late 1944, months after its technical death and despite the irrefutable evidence provided by his own engineers, someone approved it. The order was cryptic and bypassed the usual operational chain of command. It did not originate from the NKTP, nor from the General Staff. It came directly from a highly placed, unseen member of the GKO, bearing the signature of Marshal Dmitry Ustinov, Stalin's most trusted industrial commissar, a man whose authority was second only to Stalin himself and who prioritized production over prudence. The order commanded the immediate, secret reallocation of the finest engineering talent and the rarest metallurgical resources usually for high-priority projects like advanced rocketry or the burgeoning nuclear program, to Volkov's impossible vehicle. The mandate was simple: build it. Do not fail. Volkov was informed via a terse, three-line coded telegram. He stared at the signature for a long time, the paper shaking slightly in his hand. He knew then that he was no longer an engineer designing a machine. He was an agent of the state executing a political and psychological will, regardless of the consequences. By early 1945, under the heavy veil of NKVD supervision, something vast, menacing, and utterly defiant of the laws of war began taking shape in the snow-covered, heavily guarded yards of a secret testing ground nestled deep within the Ural Mountains. A monster the Red Army never intended to build, and, as Volkov's report warned, a monster it couldn't control once it existed. The construction and assembly of the prototype began under a cloud of absolute military secrecy at a facility known only by its operational designation, Polis 17, Pol 17. Located deep within a forested, frozen perimeter far from major railway lines, Polis 17 was a ghost facility, its existence denied by local authorities, its perimeter patrolled by dedicated NKVD troops under strict orders to shoot anyone approaching without the highest clearance code. The project had no formal designation in public records. It did not receive a proper KV or as nomenclature. No entry was made in official production records. No budget line existed. Funding was secretly siphoned from the heavy artillery and railway gun programs, effectively making it a phantom project running on black market resources within the Soviet industrial complex. Just a codename, scribbled on internal memos, reports delivered directly to the GKO, and heavily guarded manifests. Object P, Object P. The P stood for a word Stalin himself reportedly used when he first saw the initial, terrifying sketches of the tank's bulk, Pobeditel. The victor. It was a name of ominous pride, a preemptive declaration of victory over both the enemy and the laws of physics. As the vehicle was assembled inside the vast, heated shed at Polis 17, its sheer scale began to eclipse every armored vehicle ever conceived outside of Hitler's own delusional projects. The physical dimensions were staggering, requiring new methods of assembly, new cranes, and new approaches to metallurgy. Weight: 178 tons. The sheer weight meant the hull could not be lifted by standard heavy-duty cranes. It had to be built in situ on massive, reinforced concrete runners, assembled like a ship in a dry dock. The hull was cast in three main sections: the glacis plate, the central fighting compartment, and the rear engine block, which were then painstakingly welded together using advanced, experimental stress relief techniques. Armor. Frontal plating was a massive 295 mm, slightly under the target, a compromise reluctantly agreed to by Ustinov due to time constraints, but still utterly unprecedented, sloped at 45 degrees. The optical effect was terrifying. A vast, seamless wall of dark, triple-layer, hardened steel that looked impervious. Mobility system. The tracks were immense, designed not just for grip but for pressure distribution. Each track was over 3 meters high and nearly a meter wide. They were taller than an average man, requiring the crew to climb several meters just to enter the hull. They turned the tank into a mobile, brutalist wall of steel. The primary armament was the 130 mm S-70 naval cannon, a high-velocity, destroyer-mounted gun known for its flat trajectory and devastating kinetic energy. Adapting this weapon for a land platform was a monumental feat of engineering trauma. Recoil mitigation. The S-70 generated approximately 40,000 kilograms of recoil force upon firing. To prevent this force from tearing the tank apart, Volkov's team had to design a colossal turret ring nearly 4 meters in diameter. This ring wasn't merely bolted, it was integrated into the hull's primary structural frame. A complex, multi-stage hydraulic damping system was installed beneath the gun cradle, absorbing the initial shock before it could reach the hull. The system used a mixture of heavy oil and nitrogen gas. If it failed, the tank would simply be rendered non-operational by the recoil, or worse, the turret would be ripped from the chassis. Ammunition. The 130mm shell was not a single cartridge, it was two-part ammunition, a heavy projectile and a separate brass casing containing the propellant charge. This required 2 men in the cramped turret solely dedicated to loading, making the expected rate of fire agonizingly slow, perhaps 1 shot every 2 minutes, but each shot carried the force of a hammer of God. Object P was a tank that could survive anything, if it could ever move. The central, insoluble problem remained: propulsion. The traditional solutions, massive gearbox, multi-speed transmission, clutch, had been ruled out in Volkov's initial report as instant failure points. The design team was forced into a radical, almost heretical choice, borrowing from the only sphere that routinely moved immense weight with precision: naval and railway engineering. The choice was the diesel-electric transmission, DET, a proto-hybrid system primarily found in massive naval warships and heavy railway locomotives. It eliminated the need for a mechanical linkage between the engine and the drive sprockets, solving the gearbox failure problem by transferring power via electricity. Object P had a propulsion system that belonged in a power plant, not a battlefield. The heart of the system was detailed by a recruited team of naval engineers led by Captain Grigory Yudin, who viewed the entire land project with contemptuous professionalism. The power source: 2 paired, high-output 5th 12 marine diesel engines, adapted from existing submarine or torpedo boat propulsion, ran constantly. These were not connected to the tracks. The conversion: the V12s were coupled directly to 2 colossal electric generators, heavy, custom wound units. They churned out a massive, constant stream of high-voltage direct current DC. The drive: this DC current was fed to 4 independent electric motors, 1 set for each track unit. These motors provided the rotational power to the track sprockets. This system offered massive, instantaneous torque, the key to moving the 178-ton tank from a dead stop. There was no gentle clutch engagement, just the sudden, smooth application of immense electrical force. But the risks, as Volkov's team warned, were exponential, and all centered on the delicate balance of power. Risk of ignition, risk of overload, risk of runaway power state. If the governor fails, the magnetic field locks, and the motors will consume every erg of power the generators can produce until the copper melts. Translated from the dry, technical Russian, it might blow up. Or simply run away on its own, an electric ghost. Both predictions would prove horrifyingly true. The designated day for the first movement test was January 13, 1945. A bitter, crystal clear morning at Paulus 17. The air temperature hovered at -20 degrees Celsius, and the ground was iron hard, covered by a deep, wind-scoured layer of packed snow, perfect, unyielding terrain for testing an impossible weight. The atmosphere was thick with tension, a mix of expectation and fatalism. The assembly shed was filled with the metallic, sharp scent of cold steel and the faint, sweet smell of high-grade diesel fuel. Everyone was dressed in thick, padded greatcoats, their breath clouding instantly. The operating crew, a hand-picked mix of naval engineers, electrical specialists, and a single veteran heavy tractor driver named Dmitry Korshukov, recruited for his sheer nerve and experience with oversized machines, viewed the tank with quiet dread. They were experts in high-voltage switching and thermal regulation, not mud and shrapnel. Major Yevgeny Petrov, the chief test officer and a veteran of the Battle of Kursk, stood watching from a temporary tower, the official test logbook clutched in his gloved hands. He had personally signed the orders for the test, an act that felt less like engineering and more like feeding a colossal, metallic beast. The test procedure was cautious, dictated by Captain Yudin, the naval engineer in charge of the DET system. Diesel ignition. The 2 5th 12 marine diesels were preheated and then roared into life. The shed immediately filled with the deafening, throbbing bass of 2 massive internal combustion engines running in concert. The noise alone was frightening. Generator synchronization. The diesels settled at their optimal RPM, coupled to the 2 colossal generators. The high-pitched, metallic whine of the electrical current building, the sound of 178 tons of steel being offered life, began to dominate the air. Current feed. Yudin, watching his bank of custom-made marine voltmeters, confirmed the DC current was stable and ready. Power was fed to the 4 drive motors. Inside the cramped, acoustically damp driver's compartment, a steel capsule set low in the chassis, Dmitry Korshukov checked his controls. He wasn't connected to a clutch or gear stick, but a small, precise power regulator lever, which functioned like a rheostat, metering the vast electrical current to the motors. He expected the tank to move with the stately, grinding pace of a glacier, struggling against its 178-ton mass. Petrov gave the signal via field radio, move on command. Target. 10 meters at minimum speed. Record all thermal loads. Korshukov, holding his breath, moved the power regulator lever slowly, just a millimeter from the neutral position, toward engage. There was no jarring clutch, no grinding gearbox, only the transition from potential energy to immediate, violent action. The immense, smooth torque of the electric motors was applied instantly and violently to the tracks. The air in the compartment vibrated. The tank didn't roll, it lurched. The 178-ton machine, a mass equivalent to a dozen freight train carriages, was shoved forward with the catastrophic force of a railway locomotive hitting maximum power from a dead stop. It accelerated not like a heavy tank, but like an electric tram, sudden, silent fury of magnetic fields engaging the drive shafts. It was terrifyingly fast. Korshukov, utterly unprepared for the sheer, smooth violence of the acceleration, reacted instantly. He slammed the control lever back to zero. He expected the generator to throttle down and the massive machine to coast to a stop as its momentum was spent. But the diesel-electric transmission system was engineered for continuous, massive power output, not immediate, graceful braking. The motors, still spinning under the immense inertial load of the tank, turned into massive, unintended generators, forcing residual current back into the power system. More critically, the magnetic fields, once engaged, took a finite time to fully dissipate. The motors kept pushing. Major Petrov, watching from the tower, saw the vehicle blast through the expected 10-meter mark, then the 20-meter mark, the massive tracks digging deep, parallel furrows in the packed snow. The tank was a runaway shadow, powered by its own momentum and the lingering, untamable electrical charge. The monstrous machine surged ahead another 50 meters across the frozen test ground, heading straight for a line of empty fuel barrels. It stopped violently, but not because of human skill. Inside the hull, the intense, uncontrolled surge of current had done precisely what Volkov had feared. The 4 high-voltage drive motors instantly overheated and shut down. The thermal breakers, massive copper fuses designed to prevent catastrophic motor meltdown, vaporized with a blinding flash, cutting the circuit completely. A cloud of acrid, metallic smoke, the unmistakable, terrifying smell of burning electrical insulation and melted copper, poured from the track housings. The behemoth settled into the snow with a final, shuddering clang, its generators still screaming, its tracks inert. It was an involuntary, absolute stop. Major Petrov, descending from the tower, walked over to the stationary, smoking giant. His helmet radio crackled with Captain Udin's panicked report, thermal shutdown. Complete motor loss. We must cool for 12 hours. Petrov opened his logbook, his gloved hand visibly shaking against the cold steel of the hull, and scrawled his now famous, devastating technical assessment. The tank moves. That is the miracle, but it does not stop. That is the curse. The impossible design, the diesel-electric beast, worked. The sheer torque had overcome the 178-ton mass. But it was a power that remained fundamentally uncontrollable, a speed regulator governed by catastrophic failure, not human input. The Red Army had created a machine of unstoppable force, but it was a force that operated outside their authority. The successful, if terrifying, movement test only heightened the political pressure from Moscow. Having proven that Object P could move, if violently, the highest priority shifted to the second great impossibility, the main armament. The gun was the soul of the victor, but every structural engineer on the project was convinced the act of firing it would cripple the experimental chassis. Soviet command, driven by the absolute need for validation, insisted on at least one trial shot. The political stakes were too high to dismantle the project before demonstrating the sheer destructive capability promised in the GKO's initial mandate. The victor must shoot. Object P's main gun, the 130mm S-70 naval cannon, was a weapon of immense, focused power. Its origins lay in the refitted destroyer turret program. Naval cannons are built to accelerate heavy shells over long distances, relying on water cooling and the flex of a heavy ship's deck to manage the recoil. Volkov's team had calculated that the forces generated, approximately 40 tons of instantaneous rearward force, were equivalent to the tank hitting a brick wall at 80 km/h. To absorb this, the immense, 4-meter diameter turret ring was built of reinforced, specialized manganese steel. Beneath the gun itself, the hydraulic cylinders, filled with a special high-viscosity fluid, were designed to bleed off 90% of the recoil energy over a controlled distance of 1 meter. If the fluid ruptured, the tank would become a self-destructing weapon. The preparations for the single firing were an exercise in extreme caution and profound skepticism. It was treated less like a test fire and more like controlled demolition. Ammunition handling. The two-part shell, the long, heavy projectile, and the massive brass cartridge containing the propellant, was prepared in a separate, specialized bunker. The total weight of the loaded round approached 50 kilograms. It required 2 men to lift and load manually, a brutal dance inside the cramped turret that ensured the rate of fire would be slow and agonizing. The target, a small, reinforced concrete pillbox, used for German field artillery practice, was positioned 1,500 meters downrange. It was a target designed to absorb a standard 122 mm hit. The 130 mm shell was expected to vaporize it. The chaining. The 178-ton tank was chained down to deeply set, reinforced concrete anchors, usually used to secure long-range railway artillery during firing. 6 massive chains, each thicker than a man's wrist, were run from heavy-duty mooring points on the chassis to the anchors. The engineers feared that the recoil alone would shear the chains and send the machine skidding backward, perhaps flipping it. The evacuation. The entire crew was evacuated from the immediate vicinity. Major Petrov, Captain Yudin, and a handful of senior engineers retreated to a heavily fortified underground bunker half a kilometer away. Only a single political commissar, Comrade Zaitsev, remained to observe from a distance, armed with binoculars, insisting on viewing the moment of Soviet power. The remote fire. A long, thick electric cable was run from the firing mechanism, over the snow, to a trigger box in the bunker. The shot would be fired remotely, treating the tank as if it were an unmanned bomb. The silence in the bunker was deafening, broken only by the crackle of the monitoring equipment. Comrade Zaitsev gave the final, clipped nod. An engineer, his hand visibly unsteady, pressed the firing stud. Crack, boom. The immediate sound was a high-frequency crack, the shell breaking the sound barrier milliseconds after leaving the massive barrel. This was instantly followed by the deep, physical blow of the boom, the main propellant charge igniting. The resulting blast was not just a loud sound, it was a physical blow to the landscape. Inside the bunker, the air pressure shifted violently, making the ears pop. The entire ground beneath the concrete floor vibrated, registering on seismic equipment miles away as a minor geological event. The shockwaves, visible outside as a pale, circular ripple in the cold air, blasted a column of snow from nearby pine trees. Downrange, the shell hit the concrete pillbox. The target didn't explode, it simply ceased to exist, atomized by the kinetic energy into a cloud of pulverized aggregate and dust. The blast left a crater in the frozen earth the size of a small house. When the dust and acrid sulfurous smoke finally cleared, the engineers cautiously approached the site. The chains were intact, holding the tank fast. The recoil had pulled them taut, bending the steel mounting points on the chassis but failing to snap the thick links. Object P. It survived. Barely. The naval cannon's immense recoil had been channeled into the tank's structure, causing predictable, but terrifying, damage that spoke to the violation of engineering principles. Structural failures. The colossal turret ring, the 4-meter steel collar that held the gun, cracked visibly at the 6 o'clock position, where the weld seam joined the reinforced hull section. The steel hadn't shattered, it had yielded, straining under the rotational force. Weld seams. Several critical weld seams along the hull turret junction failed cleanly, indicating metallurgical stress far beyond acceptable limits. The tank's massive body had flexed like a thin sheet of metal under the impact. Hydraulic bleed. A plume of the special high-viscosity hydraulic fluid was leaking from the main recoil dampener piston, indicating a critical pressure seal failure. The gun was effectively out of commission until the system could be completely rebuilt. Electrical backlash. The severe, high-frequency vibration had rattled the internal wiring harnesses. Sparks were shooting from exposed sections of the electric system where the hull's flexing had sheared or shorted high-voltage cables. The tank was damaged, nearly crippled, but the fact remained, it worked. For the first time, the impossible tank had proven it could both move and shoot, even if the act of doing so nearly destroyed the vehicle and threatened to vaporize its crew. The Victor had fulfilled its destructive promise, but at the cost of its own structural integrity. 2 weeks later, the engineers were under immense pressure. They had implemented temporary cooling fixes, replaced the thermal breakers, and painstakingly re-welded the structural cracks in the turret ring, using specialized alloys flown in from a strategic aircraft factory. The GKO had demanded a demonstration of combat speed and sustained power. They wanted to know if the tank could move not just 50 meters, but 50 kilometers. The electrical team, led by Lieutenant Ivan Krylenko, a young, brilliant naval specialist whose hands were scarred by years of high-voltage maintenance, viewed the upcoming test with deep apprehension. They knew the weakness lay not in the raw power, but in the thin copper thread of the voltage regulator. The test venue was a massive, isolated, frozen lakebed adjacent to the facility, offering 6 kilometers of uninterrupted, flat, hard ice, the only place where the tank could truly stretch its immense legs without instantly collapsing the terrain. The endurance test was underway. Object P, with a fresh crew nervously at their stations, was lumbering along, its jet system humming, at a respectable 25 kilometers per hour. The noise inside the hull was a high-frequency, sustained metallic roar, demanding the crew communicate only through throat microphones. The principle of the diesel-electric drive relies on the precise regulation of the current produced by the generator and fed to the motors. A tiny, critical circuit, the voltage regulator, was responsible for translating the driver's throttle input into manageable electrical output. At the 3-kilometer mark, the tank hit a hidden seam of rough, pressure-ridged ice. The impact was violent. Inside the rear generator compartment, Lieutenant Krylenko was monitoring the voltage regulator, a custom-built unit housed in a heavy steel box. The severe shock and vibration from the earlier test runs and the gun firing had subtly damaged the mounting of this unit. The impact with the ice provided the final, fatal jolt. The short circuit, a minute internal capacitor, shaken loose from its soldering point, touched the main terminal. There was a sudden, silent blue-white flash of high-voltage shorting within the steel box. The failure state. The regulator failed instantly, locking itself in the open position. This bypassed all metering and regulation safeguards, allowing the full, unmanaged current from the twin, high-revving V12 diesel generators to flood the entire electrical system. This was the moment the designers had feared, the runaway power state. In the control room, Lieutenant Krylenko saw the main ammeters violently slam to their maximum pegs. The sheer force of the current spike bent the delicate needle shafts against the casing. The motors received a massive, unregulated spike of power, equivalent to several times their maximum operational current. The effect was instantaneous and terrifying. Object P, which moments before had been lumbering along at 25 kilometers per hour, suddenly lurched forward with the catastrophic, silent force of a lightning strike. The immense, 178-ton hull became a projectile, accelerating with a horrifying electric urgency. Major Petrov, observing from a small command vehicle further down the lakebed, watched in horror as the tank's silhouette elongated in the distance. He grabbed the radio. Object P. Cut the current. Cut the hull. The driver, Korshukov, was fighting a losing battle. He slammed the power regulator lever back to zero. Nothing happened. The magnetic field in the 4 massive drive motors was energized far beyond the limits of control, locking them into a state of unstoppable, high-speed rotation. Object P was running away on its own, a weaponized electromagnetic pulse. The speed quickly climbed. 35 kilometers per hour, then 40 kilometers per hour, a terrifying velocity for a 178-ton vehicle. The gigantic tracks pounded the frozen earth, creating deep, rhythmic seismic shocks. The noise inside was apocalyptic. The sustained, banshee howl of the generator and the deafening clatter of the tracks as the tank shook itself violently, threatening to tear itself apart. The crew was trapped inside a self-propelled disaster. They were thrown against the steel walls by the violent lateral acceleration as the behemoth veered wildly, ignoring the driver's steering input. They tried the main emergency mechanical brake, a caliper system intended only for parking. The sheer momentum of the 178 tons of steel simply vaporized the brake pads in a flash of heat and sparks, the hydraulic fluid igniting briefly. The tank barely slowed. The unstoppable run lasted for 7 nightmarish minutes. In that time, the tank covered nearly 6 kilometers of testing ground. It obliterated everything in its path. A concrete observation bunker, built to withstand light artillery, was impacted glancingly. The 178-ton mass didn't stop, it merely shredded the bunker into rubble, barely slowing its forward momentum. A reinforced anti-tank barrier, designed to stop a conventional heavy tank, was flattened as easily as cardboard. The hull flexed and groaned, stressed by forces it was never meant to withstand. Structural seams groaned under the twisting load. Lieutenant Krylenko, in the engine compartment, was frantically trying to access the manual cutoff switches, buried deep within the burning generators. He worked under a torrent of sparks and acrid smoke, his hands moving with the desperate speed of a man trying to defuse a bomb with a wrench. He failed. The current was simply too powerful. The tank ripped itself across the boundary of the lakebed and slammed into a dense section of young pine forest, uprooting and snapping thick trees like matchsticks. Object P finally came to a shattering, total halt, not through human control, but because the extreme, unmanaged heat generated by the uncontrolled current finally caused the 4 independent electric drive motors to catastrophically fail. The copper windings, the heart of the motors, melted and fused into a single, inert mass. The bearings seized. The intense heat of the electrical meltdown cut the final circuit, and the entire propulsion system collapsed. The tank bucked violently one last time, shedding 2 entire track sections that tore away from the sprockets, before settling into a smoking, silent ruin on the edge of the forest. The crew, shaken, bruised, and partially blinded by electrical smoke, scrambled out, escaping the now smoldering hull. The Victor had become a victim of its own impossible power. The technical prophecy had come true. It had run away on its own, and in doing so, had destroyed itself from the inside out. The aftermath of the runaway incident was immediate and politically explosive. Before Major Petrov could file his initial detailed report, the testing ground was swarmed by black-uniformed NKVD, People's Commissariat of Internal Affairs, security teams. They immediately seized all logbooks, data recordings, and communication transcripts. The crew was separated and taken for severe, minute-by-minute debriefings in an underground interrogation block. Major Petrov's concise, final report, delivered straight to the GKO in Moscow via coded diplomatic pouch, left no room for interpretation. The tank achieved speed far beyond design parameters but proved fundamentally uncontrollable. The failure was systemic, mechanical, and electrical, proving Volkov's initial warnings correct. The reaction in Moscow was one of fury and disbelief. Stalin, when informed of the loss, reportedly asked only 2 questions: did the armor hold? Did the gun work? The answer was yes, but the follow-up, can it be made reliable for mass production, was a resounding, impossible no. Engineer Volkov, flown in by special aircraft under extreme security, inspected the wreckage. The hull was sound, the 300mm armor pristine, and the gun tube, though its hydraulics were failing, was intact. The core promise of invincibility held true. But the propulsion was a complete loss, a mass of molten copper and useless steel. The final technical report, compiled in the spring of 1945 as the Red Army stormed Berlin, detailed the fatal flaws of the Object P concept, cementing its cancellation. The uncontrollable power equation, the inherent instability of the high-voltage DC system under sustained vibration was fatal. The failure of the voltage regulator proved the runaway power state was not an anomaly but a predictable risk. The margin between full power and catastrophic overload was simply too thin for combat reliability. Logistical complexity and repair. The repair of the system required highly specialized electrical engineers, not field mechanics. Replacing a fried, custom-wound electric motor assembly in the field was an impossibility. It would take weeks in a dedicated electrical factory to repair a single tank. Wartime resources drain. The resource expenditure was unacceptable. The amount of copper, nickel, and specialized electrical insulation required for one Object P could outfit 10 IS-3 tanks or power a small naval vessel. The report concluded that Object P was a technological dead end for the Soviet tank corps. It worked, but it was uncontrollable, unreliable, and resource-intensive. Its complexity was a logistical nightmare for wartime production, a luxury the Red Army could not afford in its final push. The decision came directly from Stalin. The project was cancelled, and the prototype was to be dismantled immediately. There would be no further testing, and no production. The vehicle was a symbol of excess and failure, and its existence needed to be expunged from all but the highest-level security archives. The secrecy surrounding its dismantling was absolute. The demolition. The single, immense prototype of Object P was cut up on site by heavy, continuous operation acetylene torches. This was a laborious, multi-week process due to the unparalleled thickness of the 300 mm armor plate. The heat required was phenomenal, turning the edges of the steel white-hot before yielding. The burial. The scrap metal was quietly reassigned to other projects, particularly the steel for the IS-3 production run. The generators, motors, and electrical components were returned to the Naval and Railway Engineering departments. The testing ground at Paulus 17 was leveled, the concrete anchors broken up, and the area reforested with fast-growing pine saplings. The memory of the impossible tank was buried, a ghost in the archives, a silent testament to wartime hubris and technological terror. Yet, the immense effort and the terrifying failure were not entirely in vain. The concept of the diesel-electric transmission, pioneered and nearly destroyed by Object P, proved its mechanical feasibility under extreme load. The engineers had discovered exactly where the limits of high torque, high-speed debt lay. The lessons learned about high current regulation, thermal overload, and high-torque electric motors were later applied successfully not to tanks, but to specialized military and industrial applications where weight was less of a concern than pure pulling power. Heavy railway artillery. The extreme precision and massive torque of the electric drive were ideal for moving and aiming colossal railway-mounted siege guns developed in the post-war era. Heavy mining equipment. The constant, massive torque and high power density were perfect for the immense excavators, industrial vehicles, and walking draglines developed for the post-war reconstruction and expansion of the mining sector. Volkov's principles found their true home in the open-pit coal mines and the vast Siberian infrastructure projects. The Project P, the Victor, never reached the battlefield. It was a momentary, terrifying glimpse into a future of armored warfare that was simply too powerful and too volatile for the technology of 1945. It remains one of the Soviet Union's most extraordinary secrets, the impossible tank that worked only on paper, and in reality, was defeated only by the uncontrollable fury of its own power, a victim of the very electricity that gave it life.